Thinking Particles and MaxScript. Part 1.
Hello. This is the first part in a series of MaxScript and Thinking Particles tutorials. In this tutorial I'll try to demonstrate how you can access through MaxScript some of the properties of a Thinking Particles system. We want to make a simple plane and put a texture on it. Then for every vertex of the plane we'll generate a particle which will take also the color from the texture of the plane in that place. Then we use MaxScript to increase the resolution of the plane. When the number of vertexes grows, so does the number of particles. Go to the Create tab, Geometry, and select Standard Primitives. Create a plane in the perspective view. The plane has 4 length segments and 4 width segments. We have to find out how many vertexes it has. We can do that in 2 ways. Using MaxScript or converting the plane to editable poly and selecting the vertex sub-object. From the MaxScript menu choose MaxScript Listener. We have to convert the plane to a mesh in order to access the numVerts property which will give us the number of vertexes. Create a new variable named planeTemp. We'll use the snapshot_is_mesh function to convert the plane to a mesh and assign it to the planeTemp variable. Now we can access the numVerts property. The plane has 25 vertexes. The other way is to add a poly-select modifier. Select the vertex sub-object level and select all the vertexes. We have to assign to each of these vertexes a particle. Let's create a Thinking Particles particle system. Don't change the name of the particle system. Leave it Thinking01. Select it and open the Thinking Particles user interface. Create a new group and name it Verts. This group will hold the particles generated from every vertex. Create a master dynamic set and name it Vert2Part. Click on the Operators tab. From the drop-down list choose Generator. Add a position-borne operator to the set. Select Pistol Shot and type 25. Increase the lifespan to 200 frames, and from the group drop-down list choose Verts. Click on the Helpers tab. From the drop-down list choose Position. Add a surface position operator to the set. From standard helpers add a node helper to the set. Click on the Pick Node button and select the plane 01 from the scene. Link the node helper to the surface position helper. Also link the position-borne operator to the particle input of the surface position helper. From the standard operators add a position operator to the set. Link the position-borne operator to the particle input of the position operator. Also link the position output of the surface position helper to the position input of the position operator. The surface position will read for every particle of vertex position from the node and will pass this position data to the position operator which will assign the position to each particle. Select the master dynamic and disable Edit on the fly. Enable Show Mesh, so we can see the particles in the viewport. From the Operators tab, Shape, add a standard shape operator to the set. From the drop-down list choose Sphere. Choose the position-borne operator and increase the size of the particles to 5 so we can see them. Close the UI for the moment. As you can see, all worked fine. Let's add a texture to the plane. I'll add a simple marble texture. Modify it as you wish. After you are happy with the appearance of the texture, select the Thinking Particles system and open the user interface. From the helpers, standard, add a texture map color helper to the set. Link the position output of the surface position helper to the surface position input of the text map color helper. Also link the UVW in and out between the two helpers. Link the color output of the text map color helper to the UVW input of the standard shape operator. Select the standard shape operator. Open the material editor. Drag the material used for the plane in the material slot of the standard shape operator. Now every particle will have the same color as the plane. Render the scene to see the result. Now we want to create a geosphere and place it above the plane. Then animate the particles from the vertexes of the plane to the vertexes of the sphere. Go to Create panel and create a geosphere in the perspective view. Increase its resolution to 6 segments, and assign a material to it. Select the Thinking Particles user interface. Select the master dynamic and create a new dynamic set. Name it Move to Sphere. From the Operators drop-down list, choose Initiator. Add a P-Pass operator to the set. From the Group drop-down list, choose Verts. From Helpers, add a Surface Position helper and a Node helper. With the Node helper selected, click on the Pick Node button and select the geosphere. Now link the nodes as we did earlier. From the Operators drop-down list, choose Dynamics. Add a Bring to operator to the set. Link it to the Verts particles and to the position output of the Surface Position helper. Test the solution to see if it works. As you can see, the particles fly from the vertexes of the plane to the vertexes of the sphere. But all happens too fast. We have to decrease the speed. Open the TP user interface. Select the Bring to operator and set the in frames value to 200. Now the speed is okay. But we don't want the particles to travel through the sphere. We need to add a deflector. From the Operators drop-down list, choose Dynamics. Add an U deflector to the set. Link it to the Verts particles and to the Geosphere node helper. Now the geosphere will also act as a deflector and the particles won't pass through it anymore. All it's okay now, but what if we want to increase the density of the plane and the number of particles? If we increase the length and width segments for the plane, we also have to manually increase the number of particles in the position born operator. To avoid this inconvenience, we'll use MaxScript. MaxScript has a function named showProperty that shows all the properties accessible through MaxScript of the object passed to it. If we want to find out what properties a thinking particle system has, we write show $thinking01. The output shows us that Thinking01 has two properties. One named Group Manager, and one named Master Dynamics. The Group Manager property has some other properties. We use the dot notation to find out what those properties are. We type show $Thinking01.GroupManager, and press enter. The properties are listed. Those properties have their own properties, and so on. In the tutorial folder you will find a script that will list all the properties of a thinking particle system. This script is named thinkingParticles.ms. Open MaxScript editor and load this script. Keep in mind that you cannot change the name of the particle system. If you change it in the scene, you also have to change it here. This script will pass through each property of the particle system and will list its properties and values in a tree-like list. Click on Tools. Evaluate all to run the script. In the MaxScript listener, all the properties will be listed. As you can see, the properties are divided in two main categories: Group Manager and Dynamic Master. The Group Manager keeps track of the particle groups in the system. The Master Dynamic keeps track of the dynamic sets, and contains all the operators used in those sets. To access a property, simply copy the code from the end of the line. This is in a multi-dimensional array-like format. As you can see, there is the value of the shot property, which specifies the number of particles created in the position born operator. You can also assign a number to this property using the equal sign. The value also modifies in the user interface. You can access through MaxScript every property that has a control in the user interface. Keep in mind that the time values are represented in ticks, the lowest subdivision of time. So to transform it in frames, you have to divide it to the number of ticks per frame, which differs from PAL to NTSC. OK. For now we only need the shot property to increase the number of particles in case the density of the plane increases. For this we'll assign a script controller to a dummy object, which will handle the number of particles. Go to Helpers and create a dummy in the scene. With the dummy selected, open the Track View Curve editor. On the X rotation parameter, assign a controller. From the list, choose Float Script Controller. You can copy the script from the tutorial folder. The file name is helper.txt. In the expression text box, type the following. Depends on $plane01.lengthSegs.controller. This means that the script gets executed whenever the length segment's value of the plane has changed. Then we create a numVerts variable that will hold the number of vertexes of the plane 01. Then we access the shot property of the position born operator and we assign to it the numVert variable. This way we will always have as many particles as we need. Click Save and choose a place to save the script. Now click Evaluate, and if there are no errors, close the script. Increase the density of the plane to see if it works. Drag the timeline slider to see the changes. All works as planned. This was the first tutorial in this MaxScript Thinking Particles series. I hope you enjoyed it. Thank you for downloading this. Visit www.community.ro for more.